Alright guys, imagine I'm sitting right next to you and we've got 5 minutes to get moles feeling normal for GCSE Chemistry. Now what is even a mole? A mole is basically chemistry's way of saying a big number counting, like a dozen, for example. A dozen has 12 things, a mole has 6.02 times 10 to the power of 23 things. It's just simply merely a unit. 1 mole of carbon atoms would have 6.02 times 10 to the power of 23 carbon atoms. This number is called Avogadro's constant. Chemistry uses it because atoms and moles are tiny, so we count them in, say for example, bulk. Now we go on to talk about what relative formula mass is and how it works, or how we work it out. Now, mR is the total of the relative atomic mass in a formula. So say, for example, I say work out the mR of CO2. We use our periodic table here, and then carbon's atomic number is 12, oxygen's AR is 16, but remember we've got 2 of them. So the mR is 1 of carbon, which is 12, 2 of oxygen, which is 16 times 2, and that would give us 44. That's properly done. You always multiply by the subscript, technically. Now, a lot of my students do find this very daunting, this whole moles topic, but it's actually not. So I've tried to break it down into very minute, simple examples, so it should all make sense. Now, the big formula to work out moles. Let me just go back here. Yeah, there you go. Now, the big formula to work out moles is mass over mR, and then that would be, if we want to work out the moles of CO2, we'll do, say, 22 grams of CO2 is there. So I do 22 grams divided by 44, which is the mR, and then I get the moles. Now, when we talk about amount of substances in an equation, this is where it starts to click. When you look at balanced equation, the number in front will tell you the mole ratio. So for example, Mg plus 2Cl gives us MgCl2 plus H2. The number in front of every single element or compound are the moles. So for example here, there's 1 mole of Mg reacting with 2 moles of HCl. These numbers are not grams, they are moles and molecule ratio. Now, for example, if I say your HCl example would be 73 grams of HCl, and if I want to work out the moles, I divide it by 36.5. Hydrogen is 1 AR, and 35.5 for chlorine. So that's 36.5. I divide them to, and the answer is 2 moles. And the ratio between Mg and HCl is 1 to 2. Now, 2 moles, when we use this as an example, we can use moles to balance equations like I've shown you here. So say for example, iron plus sulfur reacts to make iron sulfide. It's already balanced, there's 1, 1, 1, we can see that. But if it wasn't balanced, the rule is you basically only change the big numbers in front, never the little transcripts inside the formula. So you wouldn't turn FeS into FeS2 unless it's a different compound. Balancing is basically making the number of each atom on this atom the same on both the sides. Now here we've got the masses. From masses we work out their moles, and we simply just write those moles in front of the compound or the element. Then we go on to a thing called limiting reactant. Now what this actually means is it's the one that runs out first. So what runs out first is the limiting reactant. The example that I've shown you here is 2H2O plus oxygen, which is O2, gives us 2H2O. Now, the molar ratio here between hydrogen and oxygen is 2 to 1. So if you've got 5 moles of hydrogen, how much oxygen do you need? If I've got 5 moles of oxygen, of hydrogen, I need half of the amount of oxygen because it's 2 to 1 ratio, 2.5 moles. But remember, I work out the moles that I need for the other compound or element. And then I compare from the question, what do I actually have? So if I only have 2 moles of oxygen, but I needed 2.5, oxygen is limiting. If I had 3 moles of oxygen, hydrogen is limiting. Because with 3 moles of oxygen, I should have 6, double the amount of hydrogen. So if oxygen is limiting, it means you'll make less water than you could have if oxygen was unlimited. Now, the last part under moles is the concentration of solutions. This is very nice and easy. Moles, mass is equal to concentration times volume. Now, mass, we can rearrange it. The concentration unit is mole / dm cubed. Volume is dm cubed. So simply we can rearrange it and we can use this. Okay, I hope you found this useful, guys. If you have, don't forget to share this. Don't forget to subscribe my channel, and it helps a lot. Thank you so much.